Okay, so make sure that you watch the 7.1 homework video and maybe even do the 7.1 homework before diving in here, because we're just taking a deeper dive into the hypothesis tests and we're applying it to means. So explain the difference between the z-test for using for sigma using rejection regions and using the p-value. So not a huge difference. It's the same concept either way. But if I'm using a rejection region, then I say right away, well, here's a critical value for z, or if it's a left-tailed test, here's a critical value z. And if I get an x bar that lives here, or I get an x bar that lives here, I'm going to reject the null hypothesis. I get an x bar that is so far away from the null that I reject it. Well, the p-value, you're basically doing the same thing, except you're going to say, well, alpha is 0.05. So if I get a p-value that's less than alpha, I'll reject the null. That's all. Or the p-value's out to the left. It doesn't matter where that p-value lies. So you're just comparing a probability under the curve as opposed to the position of your sample statistic in relation to the mean. So so the z-test using rejection regions using the population's normal. We use these either way. The population needs to be normal to use the z-distribution, and we need sigma to be known. So the z-test using rejection regions, the test is compared with level of significance. Now, we just said that if we get the test statistic, we compare it to a critical value. C is talking about things being not normal, so this must be D, but we can read it and see. If the z-test using rejection region, we compare the test statistic to a critical value. If we use p-value, we compare it to alpha. That is exactly right. If the p-value is low, like we said in the previous section, the null must go, right? So let's jump to number 3. P-value is shown, and then we're going to talk about what we would do for each of these alpha levels. So if the alpha level is 0.01 and the p-value is 0.035, we would fail to reject the null hypothesis, right? And we would do so because 0.0353 is greater than 0.01. This is a false statement there, okay? If the p-value is low, the null must go. Now, when alpha is 0.05, what are we going to do? Now, the p-value is low, right? We're considering 0.05 to be low. 0.0353 is less than 0.05, so we reject the null, okay? And same thing for the last one. We would reject the null because it's less than. If the p-value is low, and low can be relative, right? One person says 0.05 is low, and then the next time we say 0.01 is low. So we have to figure out what they're claiming to be low or not low in a given test. Find the p-value for a left-tailed test with a z-test statistic of -1.3 if the significance level is 0.1. So a couple things. The significance level doesn't affect my p-value at all. So I want to clear that out. That's sort of, they're putting that out there, but we don't really need it. I know that this is a left-tailed test, so I'm going to draw my normal curve like we've been doing for quite some time. And they told me that the test statistic, so my null hypothesis lives here, that would be a test statistic of a 0. But they're saying you got a z-score out here of -1.3. So what's the p-value? It's just the area to the left of that. I've been doing this for a while. Let me see if I can grab my calculator. Thought I already had it opened up. But your graphing calculator, especially if you bought one, is going to be the easiest way to go ahead and dive into this one. So how do we find that area? If you remember, this is second in the variables key, and it's our normal CDF. Okay? So what's our lower limit for that picture I just drew? Negative infinity, right? Like -1,000, -1,000,000. The upper limit is -1.3. And of course it's a z-distribution, so it's a mean and standard deviation of 0, 1, respectively. So I get 0.0968 or 0.097. Let's see how many decimal places they want. 4. It goes all the way out. Let me make sure I rounded right. Yep. Check that. So what would we do with that p-value? Well, it's less than 10%, right? Alpha is 0.1. 0.0968 is less than that. So since alpha is less than, and they're using less than or equal to, you're not really going to have a p-value equal to alpha. We'll reject it. So let's jump to numero 7. Two-tailed test. I want to look at this one with you. because this could be confusing. So we have a test statistic of negative 1.65. It looks similar to the last one, but when it's two-tailed, which is what's suggested here, then not only are we looking at the p-value that's out here, but this, remember, it's a two-tailed test. So you could have had a value that fell out here. Both would be significant. So we have to find the area in both tails. Easiest way to do this, subtract the area you don't want. Oops. So if I did 1 minus the normal CDF from negative 1.65 to 1.65, mean of 0, standard deviation of 1. That'll give me the two tails. Okay? Or, what if we normal CDF like we just did from, let's say, negative infinity to negative 1.65, mean 0, standard deviation of 1. And what will we do? Just double that. So either one of these will give us the answer that we want. So if I did 2 times 1 tail, second pars, normal CDF, negative infinity to 1.65, bop, 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 1.9. Okay, so 1.9 makes no sense as a p-value. Hopefully that made no sense. So I just went back to troubleshoot the issue here, right? I forgot my negative sign. That's supposed to be negative 1.65, negative 1.65, right? Negative 1.65. That's what we would double. That's what we wrote here, negative 1.65. So now when I execute that with the negative sign, I get 0.049, and then I would double that. If we multiply that by 2, that's just area in one tail, I get 0.0989. Okay, so if, what's our alpha value here? Alpha is 0.09, kind of a weird alpha value, but we would fail to reject the null, right? Our hypothesis, our p-value is larger than that particular alpha. Okay? Number 8, match the p-value with the graph that displays its area without performing any calculation. So if z is negative 2.21 and z is negative 0.75, which graph displays the correct p-value? So the p-value for negative 2.21 is going to be a little bit smaller, right? So this is the smaller of the two p-values. That one must go with graph A. So graph B must be the bigger p-value, and graph A displays the smaller p-value, right? The p-value is the area under the curve. Because the p-value is shaded area, right? Sorry about that. To be more specific, not related to the shaded area, but equal to shaded area, right? Okay, let's jump to 12. Find the critical values and the rejection region for the type of z-test with the level of significance alpha. Include the graph with your answer. So here we have a right tail test with alpha of 0.02, and what I want is the critical values. So, got to draw a picture for this so you can picture it. It's a right tail test, so I'm only going to be impressed if something falls really far to the right. So the null lives here, and our alpha value is 0.02. So what that means, not a p-value here, we're saying what is a test statistic that is going to impress us. So if you remember, this is an inverse norm problem. We are going to inverse norm 0.98, the area to the left, mean of 0, standard deviation of 1. Everybody should have inverse norm. Some of you don't have inverse t. That's okay. We'll cross that bridge when we get to it. So inverse norm, the area to the left of that would be 0.98, mean and standard deviation of 0 and 1. So what would impress us would be a test statistic greater than 2.05. Hopefully they don't want more than 2 decimal places. 2, yeah. And since it's just a right-tailed test, we only need the one answer. It's just a positive. Okay? So the rejection region is where z is greater than 2.05. If something falls into that region that I shaded, that's where we would reject the null hypothesis. That would look like this guy here. Okay. Find the critical value and rejection regions for the type of z-test with level of significance alpha. Include a graph with your answer. So now we got a two-tailed test, alpha 0.08. So I do want to make sure we think about this. If alpha is 0.08, then what happens is we have to split that up. We could get a significant result in either tail. So the null lives here. All right. So we have 0.04 here and 0.04 here. Makes it harder to reject the null hypothesis. So when it's a two-tailed test, you have to divvy that up into the two tails. So we're answering the question, what would this guy be? But he could also be negative. It's going to be the same number. Okay? And we do it the same way. It's inverse norm, 0.96, right? If this is 0, 4 here, then the area to the left of that is going to be 0.96. 0 and 1. You don't need that comma.
I hear you.
So 1.75. But this is going to be a plus or minus. Let's see if they'll allow me to put a plus or minus in here. Yeah, we can say plus or minus 1.75 because it could be both. All right, so look at this toolbar down here to get that plus or minus symbol. And we're good. Okay, I'm going to jump to number 16. Yes, believe. Okay, so now we'll use technology. I want to make sure I reviewed what this looks like on our calculator. So the claim is that mu is greater than 1210. That's going to be our alternate hypothesis. Alpha is 0.06, kind of a weird alpha value, and sigma is known. So, like we did in class, this is stat, it's under tests, and this is a z-test. Okay? We don't have the actual data. I don't have the raw data. So the null hypothesis, we're going to plug in that 1210, right? Sigma is known, and they're telling us it's 207.93. Then we have our x bar, our sample statistic. They gave us that as 1232.67. And then finally we have our sample size, which was 250. So we have to think about our alternate hypothesis by what they tell us here. The claim is that mu is greater than 1210, so that's going to be a right-tailed test. So that's going to be our greater than symbol. All right, and now let's go back. We'll go ahead and get our calculations and everything. We'll be able to draw back on this. But let's go ahead and set up our null and alternate hypothesis. This is my alternate, right? Remember, my null always has to have an equal sign, so I need the complement of this. If this is my alternate, greater than 1210, and you have a bunch of these that have the sample statistic in them, we're not testing that. We're testing this parameter. So our null and alternate has to revolve around 1210. So I need an alternate greater than 1210, and here's its complement in the null. I'm either less than or equal to 1210, or I'm greater than 1210. Okay, so that would be my correct null and alternate hypothesis. The standardized test statistic, well, the calculator already did that for us. Let's just go back and grab it. It's 1.7238 or 1.724. Let's see how many decimal places we need. Just 2. 1.72 will be good then. Okay, and then what's the p-value? We have it. Our calculator did it for us. 0.0423 0.036. So if we have to go to 4 decimal places for this, it's going to be 0.0424. But 3 decimal places is enough. 0.042. Okay. What's our outcome? Well, let's look at alpha. The alpha level is 0.06, so our p-value is low compared to that, right? So the null must go. So we would reject H0 at 6% level. There is enough evidence to reject. To support. So we're rejecting the null hypothesized claim, but we're supporting this claim. Okay. So a little bit of linguistic gymnastics there, I suppose. So that was 16, right? Let's take a leap over to 21. All right, so now in this case, I have the data. So what I wanted to encourage you to do with this one was use StatCrunch, okay? So we can answer the first question by reading the narrative, but the length of time it took a random sample of 32 former smokers to quit smoking are listed. Assume the population standard deviation is 4.7. That's how we know it'll be a Z-test. And then, is there enough evidence to reject the claim that the mean time it takes smokers to quit is 13 years? So they're not giving us a direction for this. They're just saying it's 13 years. So that would just be that it equals 13 and it's a two-tailed test. Okay. You would think we might be interested in seeing if it's more or less than that, but the way they read the narrative, it's more or less. So come on, StatCrunch. Okay, so sometimes StatCrunch just doesn't open on my first try, so we're good now. So here I want to go to Stat, and I want to go to Z Stats, okay, where we can run a Z test statistic. So what we have here is data. We don't have the summary statistics. It doesn't give us the mean and standard deviation and so on. So I want my variable 1, okay. We are going to perform a hypothesis test. So we need to double back and see what that test was, 13, right? So the null hypothesis is that it takes 13 years to quit smoking. We could do confidence interval as well as we want, but we'll just roll right through this. So look what I get. I get my sample mean, I get my standard error, I get my Z-stat, 2.44, and I get a p-value. That's what I wanted. So I'm not sure why StatCrunch gave us the wrong Z statistic on that last one. I'm going to try one more. I had 2.44 from StatCrunch, and the answer said 2.3. So it's bizarre. We'll try another one, see what happens here. Hopefully it doesn't give you problems when you're running this. So this one's a little bit different. It's a right tail, so I wanted to look at it with you. This politician claims that that the mean salary is more than 82,000. So that's the alternate. So we need to find more than 82,000 in an alternate. Here it is. Right? Never have an equal sign in the alternate. So the complement of that would be less than or equal to 82,000. So that's the correct null and alternate. Again, let's see if we can run this in StatCrunch. So I go to Stat, Z Stats, and I want one sample with data. So my variable 1, I haven't named it. This is not two-tailed now, so it's going to be one-tailed. So we need to go back and see what his specific claim was again. He said that it's more than 82,000. And the population standard deviation is 8,300. So this is going to be greater than 82,000. And this does not ask me for the population standard deviation. That's where I think, here we go. This could have been our problem in the last one. Let's see. let's tell them that our standard deviation is 8,300. Because with the z-test, they really ought to ask us for that. We're going to go ahead and tell them, look, it's supposed to be 8,300. I suspect they used the sample standard deviation on the last one, and that's why we got 2.44. So watch that on this one. Make sure we use that standard deviation that they give us. I'm surprised they don't ask us for it somewhere in here. If we did this on the calculator, they would ask, but I'd rather you do this on StatCrunch since it'd take you a lot longer to type all those numbers into your calculator. So let's see what happens here now. We get a z-stat of 1.44 if I round that. So let's cross our fingers that it used the right standard deviation that time. Yay. Okay. So that's the bug. Make sure you tell it the population standard deviation is known. Usually if you're picking a z-test, they're going to ask you for that. So we know our p-value will be okay now. P-value is 0.0755. And that would be 6, right? That would round if we go 3 decimal places.